In this session, we'll discuss about the limitations in impulse invariance method. To understand the limitations, first take the relation between Z and S plane using impulse invariance transformation technique, that is Z equal to e power st. Let's take an S plane. Assume you have a pole at S1 and you want to know the location in Z plane, right? Assume, like, let us take a unit circle r is equal to 1, right? So suppose S1 is, let us take S1 is sigma 1 plus j omega 1. What is corresponding Z1, the location in S plane? You know that S1, the sigma 1 is, it is at a distance of sigma 1. Sigma 1 is negative, so definitely this pole lies inside the unit circle, right? So S1 is sigma 1 plus j omega 1. Then what is Z1? You know that it is e power sigma 1 t into e power j omega 1 t, right? Let us assume a second pole which is on the top of your S1, and assume this is your omega 1, and which is at a distance of 2 pi by t from our omega 1, that is, this is omega 2. So what is omega 2 here? Omega 1 plus 2 pi by t, which is at a distance of 2 pi by t, right? So what is S2 now? S2 is omega sigma 2 plus j omega 2. So here sigma 2 is nothing but it's a sigma 1. Reason is both are at the same distance, right? Sigma 1, this is sigma 1. So I can write sigma 2 is sigma 1. And j, what is omega 2? Omega 2 is omega 1 plus 2 pi by t into t. Then if it is S2 is defined like this, then you want to know where is the location of S2 in your Z plane, right? The corresponding Z2, where is the Z2, right? So for that, let us take Z2, which is due to the mapping of S2. What you can write, this is e power sigma 2 t into e power j omega 2 t. So e power sigma 2 t means, from this expression you know that this is sigma 1 t. What about e power j omega 2 is, which is omega 1 plus 2 pi by t into t. And if you rewrite this Z2 is e power sigma 1 t into e power j omega 1 t into e power j 2 pi by t into t. So here t cancel. What you have now? This is e power sigma 1 t into e power j omega 1 t. What about e power j 2 pi value? You know that this is 1, right? Then I have 1. So what is this final Z2? Finally you got Z2 is equal to e power sigma 1 t into e power j omega 1 t. What is this expression? You know that this is your Z1. So Z2 is equal to Z1. So from this, if you observe that if you have two poles at a different locations but they are occupying the same location in Z plane, means suppose S1 is mapped to this point. Suppose S1 is mapped to this point. Where is the location of S1? The same point, right? It is called many to one mapping, right? So what is actually many to one mapping? It is S1 is at a low frequency, right? Omega 1 frequency, and S2 is omega 2 frequency. It is a higher frequency, right? So higher frequencies are occupying the location of lower frequencies, right? This is called aliasing effect. So this is a limitation in our impulse invariance. So it will create distortion. So generally impulse invariance method is used to design low pass filter. Not only this, if you take any pole which is at a distance of 2 pi by t, which will occupy, suppose I have S1 and I have another pole which is at a distance of 2 pi by t from this S1, that will also occupy the same position. This is the limitation in our impulse invariance transformation. This can be avoided in using bilinear transformation method.